Hello, I'm Patrick Feeney, and I'm going to be presenting NovelCraft, a dataset for novelty detection and discovery in open worlds. In order for artificial agents to succeed in changing environments, they must be able to detect and adapt to novelty. This poses a problem for agents using visual data, since visual novelty detection typically uses object-focused images, which depict the object of interest prominently with little occlusion. New scene-focused benchmarks are needed to evaluate novelty detection for objects subject to occlusion and depicted in only small parts of the imagery. We introduced the NovelCraft dataset, which includes both image and symbolic world state data detailing an agent completing a task in a Minecraft-like world. These images are scene-focused and taken from a complex environment. We evaluate novelty detection methods extensively, going beyond the typical area under ROC metric. And finally, we evaluate how well generalized category discovery models perform on open world data. NovelCraft contains data for more than 130,000 frames, even after filtering out data that does not have a clear visual label. On the right, we have some samples showing various frames from random agent runs in the dataset. The novelties outlined in orange can be as small as 1% of the pixels in the image, much smaller than would be seen in an object-focused dataset. Additionally, each frame has symbolic world state data stored in JSONs. This symbolic data contains a representation of the player's state in all objects and artificial agents in the world. Our visual novelty detection experiments confirmed that the state-of-the-art NDCC and Odin methods perform well at their reported area under ROC metric. However, the simpler ensemble and autoencoder models are surprisingly competitive for AUPRC, with ensemble performing best by a wide margin. Autoencoder models also perform surprisingly well when measuring performance at a fixed TPR or PPV value. This regime represents when strict constraints on false positives or false negatives are needed for the novelty detection models. We additionally examine multimodal novelty detection for identifying whether an environment is novel over the course of an episode, where the agent attempts to complete a task once. Multimodal models can improve performance on this task while reducing the time needed to detect a novelty. Our generalized category discovery experiments examine clustering accuracy on NovelCraft. We find that imbalanced classes are challenging for existing models, causing small labeled classes to get clustered with larger labeled classes, and large labeled classes consuming smaller unlabeled classes. We share all of our raw data along with dataset and methods code available with these links. I have also created this GCD datasets repository, which provides a shared interface for NovelCraft and other common generalized category discovery datasets.